Hi, my name is Ankit Thapar. I am in the Computer Programming Analysis program, and this is my last semester, so I'll be just finishing in April. So today I'll be going over the assignment 2. So in this assignment, we created a network monitor which will monitor all the multiple interface monitors. And so basically in general what it does it launches different interface monitors and there is no limit to it, so it can monitor any number of interfaces. So it launches them and then it receives commands from them, like maybe in this assignment like the link down, and then in response to these commands it will send a signal like maybe what do you say, set link up. So basically it will just keep communicating with all the interface monitors, keep receiving, and then in response to that it may send different signals so that basically it can recover. Like if it's like link down, it may send the sync basically to set the link up back again. So that's how it will work. So first I will go over the code and then we see how it basically works. So here let's starting from the main. So we are setting up the signal handler here. So if we just go to the code for there, so in the signal handler first just is the printf statement and then we are calling this shutdown all. So basically shutdown all is all about like the freeing the resources and everything. So here we loop through all the interfaces, so whichever network, basically whichever interface monitors are connected, so we're going to loop through it, and then what we are doing is we are sending them, we are writing to the interface monitors like shutdown. So basically sending a signal to the interface monitors to shut down them, to close their connections and everything, and then we just printf, and then we again looping through it, and then we are waiting to for the read one. So here what we are trying to do is we are just trying to read. So basically again we are looping through all the what you say interface monitors, and then what you say we are trying to read, and once you try to read, we whatever the interface monitor has sent in response to the shutdown command, we basically read that and print it to the screen. And then we are just here closing all the socket connections. So client fds basically is an array of all the sockets to the basically interface monitors. So if there are 3 interface monitors, we'll have the 3 sockets, so we're just trying to close the connection to them. And then we run this cleanup command. So in this cleanup command here, what we do is, so we close the main file descriptor and basically we're just freeing up the resources. Like it's pretty much clear here. So after doing the file descript, so after setting up the signal handler, so first thing is obviously asking the user how many interfaces it wants to monitor. So just simple printf, scanf, just basic error handling going on. And then we're creating just the arrays to store different resources like the interface names, like child file descriptors. So whatever the interface monitor file descriptors and even the process IDs and everything. Just the basic error handling going on, that if we are not able to create it, we just say memory allocation failed. We are not able to allocate the memory or the resources for storing these things. And then we're just asking the user to enter the names of the interfaces. So just a basic for loop. So we're asking the user to interface, and then we are just using fgets, and then we're just copying it to what you say, like we're using this sts pen, we're copying it to interface names. So basically let's suppose user enters 3 interfaces, what you say, ens33, lo, or maybe ens160. So this array will hold all those basically names. And then here we are setting up the socket. We need a socket so that the interface monitors can connect to that socket and we can communicate to them. And then what we are doing is we're setting up the listening and binding on that socket, again pretty much clear. And then here we are looping through all the network interfaces. So this is the main part. So what we're doing is here is, so we are looping through all the, let's suppose we have 3 interfaces or 4, and then we are creating a child process which will be linked to that interface monitor. So each process will be linked to a particular interface monitor. So that's what we are doing. And then we are also passing the interface name as an argument. We'll see in the interface monitor.c how we are using that particular name. And then here we are waiting for the connections. We are using this accept, so that because the once the interface mentors will try to connect, we need the accept. So basically so that once we execute or launch different processes for the interface monitors, they'll be trying to connect to the network monitors. So we use this accept command, and then what we do is we are basically trying to read. So because once the interface monitor is ready, it will send the read. So we basically read, and then we're just printing it like we received read from the, not basically read, or received ready from the interface. And then we write the monitor, because once we receive ready, okay, we are okay to send the monitor now, so that okay, now you can start monitoring. And then we receive again, because I think in response to the monitor, the interface monitor is expected to send that started monitoring or something. So what we do is we basically read, so and then we just printing like that it's monitoring now. So just the basic simple things. After that, this is the main loop, what you say, the loop basically, which is a infinite loop, because we can see here the condition is 1. So it's an infinite loop which basically keep monitoring all the interfaces. So what it does is it keeps a watch, so that when an interface monitor sends something, maybe link down or something, then it can respond. So here we are using the use of FD0. So what we are doing is, so the read FDS is basically a structure which stores all the sockets or basically the file descriptors that has something to be read or that we need to watch, like, okay, we need to monitor these sockets or something like that. So first we are doing is we are setting it to 0, means we are just, what you say, making it empty or just deleting everything from it so that nothing is there for now. And then we loop through all the interfaces and then we add it like one by one to this structure, read FDS. And then here what we are doing is we are using the make use of the select command. So what is a select? So select is like a system call, so that it's like a pause. So here the program will pause and it will wait like until we have something to be read. So that's the thing, until like some socket has sent some information, like maybe link down or something, it will wait. And then what we do is we'll loop through all the interfaces so that we know, okay, which socket has sent that thing. So for that particular part, we'll use make of FD set. So what we're trying to do is we're just trying to see that which client FD, so basically which socket or which interface monitor has the data to be read from, like which has sent basically a particular message like ring down, whether it is LO, whether it is ENS33 or whether it is ENS160, which interface monitor has sent information. And then if it's linked down, what we do is we send the link up, we use the write to send link up. And yeah, that's pretty much it. So that's how network interface monitor works. We create a socket connection, we accept the connections, and then we're just continuously monitoring that whether an interface monitor is sending something or no. And then we have the interface monitor file. Let's see how basically it works. So going to the main function, we are just validating the number of arguments are 1 only, because we in the previous file we said we will receive the interface name as a argument, and then we are just copying it to the iFace variable. So whatever the interface name is, we're just copying it to iFace, and then we are setting up the signal handler here. So signal handler here doesn't much do anything, just for stopping the program. So running is equal to 0. And then what we do is here we are trying to create a socket here. So obviously we need a socket to make a connection to the network monitor. We're creating a socket using the connect command to make the connection, and then we write the ready. So once we are connected, we write the ready. So then we'll definitely wait for the monitor command from the network monitor. And then if it's a monitor command, then we start monitoring. We write back to the network monitor that we have started monitoring, and then we just run the monitor function. So looking at the monitor function, it may look big, but simply what it does is it basically collects the statistics. So basically we open that file, this file sys class and everything, we get the information from there. We get the information like RS packets and everything, and then we just display it to the screen. And here I have declared like the different variables to be used, and then we are just reading it. So read bytes, read packets, we are just storing it in there. And then what we are trying to do, let's see. So now here we are trying to get the carrier up count and carrier down count, because the path is a bit different. Here we need to go to statistics, so we are just getting them like individually. And then we are monitoring here something. So we are just monitoring like if there is a change in state. So basically like if the current state is down and the previous was up, it means it has gone to down. Or if the current state is up and previous was down, it means it has went back to up. So we are just trying to monitor it. And then we're printing all the statistic information, and then we're going to monitor our socket. So we use this again, the same structure, and then we put our socket to the read FDS so that we can continuously like watch for it, like whether it has something to be read. Because if we are sending, what you say, link went down or something like that, so if we are just printing F, so if we are sending link down, we may receive something from the network monitor in response. So then again we have the select command, so it will pause, we wait. If it has something to be read, basically the network monitor has sent something, so it's just waiting for that. And then we just read it, and then we see if it's the message sent link up, so we just call this function set link up, which was already given in the assignment. So set link up basically makes use of the IOCTL. So what we get the flags, and we store all this information in this structure IFR, and then we set the flag to back to up. And then we make use of this ICOTL commands so that we can set. So we basically created a socket where we need to change the information, and then we set the operating system, basically the state, back to up. And then we just close this file descriptor. So that's how basically it works. And then yeah, once it's shutting down, we write stop, basically done, back to the socket, basically back to the network monitor, and then we just close the connection. So that's how basically it works. Let's jump see how it basically works in practice. So let me just go back here. Oh, okay, I hope it's okay. Let me just log back in. So I have the files, all the files here. So let me just run with the sudo command. So why do we need sudo? Because we are trying to change the state and we need the admin permission for that. And then I just ask the password. So let me enter the number of interfaces, maybe hello, maybe ENS160. I don't have ENS33 on this Ubuntu one, so I'm using ENS160. Let me press enter. So we can see it has started information like RX bytes is visible, ENS160, its state is up. We can see its state is up. So let's try to change the state to down. So let me just open a new terminal. Let's try to change the state to down. Let's see if I have executed this command somewhere. Yeah, so let's try to change it to down. So I send this message. So I've sent this message. So we can see here, it says link went down. So it says set link up and the link is back up. So I'll just close it immediately because we will not be able to monitor it in the real time. So let's go back up. So link is back up. So we can see here, it says link went down. So if we see before this one, for the ENS160, the state is up. So here the state become down. Even we can see the change in the increments here, that the down count is 3 now, because earlier down count was 2. Okay, and now it's basically 3. And once we say, and then the network monitor basically send the sent link up to back to ENS160. So to the interface monitor is sending back the message, and then we see where it went back up. So let's go down. It says link is back up here. So we can see for the ENS160, the state up is back. We have the up count, down count to be back to 3 again. So let's try to verify this information. So let's try to maybe use ifconfig. Maybe ENS160. I hope it works. I am not good with memory and stuff. So if we see with the ENS160 here, so this is the last information we received here. So I just forgot. So when we are shutting down, we send the shutdown to interface and everything. So this is the last information of both the signals. So for the ENS160 and what do you say, ENS, I would say LO. So here we received done. So we received done from the LO before. It can happen because these processes are running independently. It's not a process that one thing will happen first and then it will jump to the next thing. So let's see the information here and let's try to confirm. So it should be around estimate to be same. So we have the TX packets to be 423, and if we see here, what do you say for the ENS160, if we say TX packets, so we have 393, so approximately close. And then what we have, maybe TX errors to be 0, blah blah blah, RX packets to be 1257. Are we have the same thing? So what do you say, RX packets to be 1233, again pretty similar, like because the last information encountered. Let's try to see what you say, the state is up or back. Let's try to see for the ENS160, the state, it says up. So, and even in the last one, it was up. So we successfully went it back to the up one. And so yeah, basically all the information basically matches and everything. So let's try to see the count and everything. Carrier up down and carrier up down. I just kind of forgot like what was the command. Maybe let's see if I remember in the statistics or maybe in the code I would have. So let me just go back to the code and look at it. What was for the, because I need to know the path for that. Sometimes I just forget that. We have this called carrier up count. So let's see. So we have this carrier up count, CARRIR, and then we have up, and then we have basically count. So we have, yeah, the up count is 3 and we have this up count to be 3. So yeah, basically all the information is verifiable. We are handing the shutdown signal gracefully. Link is setting back to up. So I think everything is working fine. So if I need to evaluate myself in terms of the requirements, I would say I will give myself 10 out of 10. I think all the requirements are satisfied and I have tested it again and again, and it has always worked very well. And if I consider my part, my understanding part, yeah, I have used generative AI, I will not lie for that, but I understood like most of the parts. I would say at least some of the parts I couldn't understand because of the shortage of time. So maybe I would give myself around like 8 or 9 out of 10, like because I understand all of the things, like most of the things basically. So yeah, that was it. I hope you enjoyed the presentation. Thank you. I'll just close the recording.